Okay, hello everyone. Today we will be talking about differentiation in our video. So what is differentiation? Differentiation is the action of computing a derivative. The definition is the change in y over change in x. We will be using differentiation and apply it to a method called optimization. Optimization is the collection of mathematical principles and methods used for solving quantitative problems in many disciplines including physics, biology, engineering, and economics. This picture shows a rough sketch of what we will be talking about in this video. As you can see, from point A to point B, it is 50 meters, and from point B to the school is 20 meters. Let's say a person has a cycle speed of 5 meters per second from point A to point P, and that same person has a walking speed of 1 meter per second from point P to the school itself. How far would this person cycle before getting down to walk to school to minimize the time taken to reach the school itself? Based on the previous picture, we define the time spent cycling from point A to point P to be at x over 5 seconds. We then define the walking time from point P to the school itself to be y over 1 second. The distance of y can be obtained using Pythagoras theorem as seen here. The total travelling time as seen here is from point A to the school itself. Afterwards, we will substitute the value of y and get the total travelling time as seen here. We will then perform the first order derivative to find the maximum and minimum values. In order to obtain its critical numbers, we equate the derivative to 0. And after some mathematical arrangement, we obtain the answer of 24x squared minus 2400x plus 59,600 equals to 0. Now, we will use the quadratic formula in order to obtain our critical points. Subbing in the values based on our previous results, we will get an answer of 150 plus minus 5 square root 6 over 3. Looking here, we can see that the answer 150 plus 5 square root 6 over 3 is out of domain. The reason why is if you were to take this answer and put it in your calculator, you will get an answer of 54.08 meters. This will not make sense because from point A to point B, the distance is already 50 meters. And the x value is the distance between point A to point P. Hence, having an answer of 150 plus 5 square root 6 over 3 is out of domain. Also, we understand that critical points occur when the derivative of a function is equal to 0 or it is considered to be undefined. We take our denominator and equal it to 0, we will get an x value which is considered undefined. Hence, the only critical point that we will have is x equals to 150 minus 5 square root 6 over 3. Now, in order to prove that our critical point is the minimum value, we will have to conduct a first derivative test. We do this by subbing in a value into the derivative of the function which is less than our critical point. We can see that our answer is of negative value. This means, or rather this shows, that the function of the derivative is less than 0, which also means that the function before the critical point is decreasing. Next, we do the same thing again, but this time we sub in a value greater than the critical point. We can see that it is greater than 0, which means that the derivative of the function is increasing after the point. After combining the two, we can prove that the critical point is of minimum value. Now, we will take the critical point and sub in to the original function, and that will give you the total travelling time. This proves in order to achieve the minimum time taken to travel from point A to school, a person would have to travel and park at the distance of 150 minus 5 square root 6 over 3 before getting down to walk to school. In conclusion, this shows that differentiation can be used in our everyday lives, and this also shows the minimum time taken to travel to school.